Welcome to video number 4 on PIAAC Data Analysis in Stata. The video tutorial is designed to give a practical guide to perform PIAAC data analysis in Stata. The target group of the videos are researchers who have at least some experience in data analysis with Stata, who have little or no experience with the analysis of PIAAC data, and who are interested in whether the data are suitable for their research question. This video shows you how to work with Repest, a Stata do file written to facilitate the analysis of international skill assessments such as PIAAC. The Repest command considers both the plausible values and the complex sampling which are necessary for the correct estimation of standard errors or statistics, including the skill assessment, automatically. Repest was developed by Avisati and Kessler, and you can have a look at the two references cited here to get more information on the command. To use the Repest command, you need to download it. Just type the displayed command in your command window in Stata. We start by looking at the general syntax of the Repest command. In the next steps, we will look at the syntax for specific examples and perform the analysis in Stata. On the left-hand side of the Repest command, we have the keyword PIAAC, along with any if or in statements. The keyword activates the parameters associated with the PIAAC survey design, that is, weights, variance estimation, and 10 plausible values for the cognitive skills are taken into account. If or in enable sample restrictions. Command can be any built-in command in Stata, for example, mean or summarize. The command options specify the options for the respective Stata command. The Repest options specify all further options, and we have a look at this on slide 8 and 9. There is a second form of the Repest command which simply adds the prefix Stata to command. You have to add this prefix if you want to use E-class commands, which are typically regression commands such as reg for linear regressions, logit for logistic regressions, or qreg for quantile regressions. The other options of the command are equal to the first form of the Repest command on the previous slide. Next, we have a look at the main options you have to specify within the Repest command. By produces separate estimates by the levels of a specified variable. So, for example, it is possible to estimate the average of skills over countries. Over jointly estimates across the different levels of a variable list, and it is possible to test for differences between categories. With results, you can keep or add statistics calculated during estimation and create new results with a combine function. Outfile creates a Stata dataset containing all estimation results. If you use the Outfile option, the results are not displayed in the Stata output window. And if you still want to see the results in the output window, you have to include the Display option. And next, we will look at some examples to better understand the structure of the Repest command. Our first examples are descriptive statistics on average years of education and literacy skills, overall and by gender. Literacy skill dispersion, overall and for men between 16 and 34 years. Percentage of respondents at each numeracy level, overall and for the employed population. A cross-table of numeracy skills in native language. And the correlations between all three skill domains. We start with average years of education and literacy skills, and this is how the syntax should look like. On the left-hand side, we have the PIAAC keyword, so in this and all following examples, the plausible values and complex sampling design are automatically considered. The means command calculates the average. Yearsqual is a continuous variable on years of education. pvlit is the continuous variable on literacy. And one important remark here. Any plausible value variables must be included using an @ character in place of the plausible value number. The @ character indicates the presence of a variable with plausible values and will automatically include a loop over the right number of plausible values, in our case 10. With the by option in this example, we calculate the results separately for all countries in our dataset. And with the average option, we can also calculate the average over countries. If we also add the over option, we can obtain average education and average skills separately by gender or any other categorical variable. This is the syntax for literacy skill dispersion. As we do not only want the results for the full sample, but only for men between 16 and 34 years, we can also include the if option and restrict our sample with the gender and age variables. We use the summarize command to get percentiles. More precisely, we want the 5th, the 25th, the 75th and the 95th percentiles. Again, as we are interested in literacy skills, we use the variable pvlit with the @ character. With the by option, we calculate the results separately for all countries. But with the levels option, we only obtain the results for certain countries. The next example is on levels of numeracy skills. As we do not only want the results for the full sample, but only for employed individuals, we can also include the if option and restrict our sample with the variable cd05, which provides individual employment status. The command frec calculates frequencies. For numeracy levels, we can simply include num levels with the @ character. With the by option, we calculate the results separately for all countries. And this time, we also use an output file, which we call Repest example3, and this will be in Stata format. We have a closer look at the format when we look at the examples in Stata. Now we come to numeracy skills and native language. This example is similar to the previous one. We use the frequencies command and also use the over option to get the levels of numeracy skills over native language. As we do not specify the by option here, we will get the results pooled for all countries in our dataset. And there is a second version to obtain information on numeracy skills and native language. Instead of frequencies of numeracy levels, we can also have a look at the average skills with the means command. We use the over option to get the results over the variable native language and also test for differences in skills between the two groups. The last example is on the correlation between all three skill domains. So we use the corr command. We include all three skill domains and could include even more variables here. With the by option, we calculate the results separately for all countries in our dataset. And with the average option, we can also calculate the average over countries. And now we look at these commands in Stata. As said before we start with any analysis, we have to install the Repest macro. If we do so, we can also use the help on Repest. Next, we define some globals on the path where we saved our data, the path where we save our log files, and the path where our results will be saved. Then we save a log file, and then we load the small dataset including 5 countries which we will use for our analysis with the Repest command. We first tabulate the countries in our dataset, and then we go to the first example. The first example we just talked about was calculating average years of education and average literacy skills. The means command calculates the average. Yearsqual is a continuous variable on years of education. pvlit@ is the continuous variable on literacy. And as indicated before, the @ character indicates the presence of a variable with plausible values and will automatically include a loop over our 10 plausible values. With the by option, we calculate the results separately for all countries in our dataset. And with the average option, we can also calculate the average over all 5 countries. We just have to include their numerical codes here. And here we have the results. First, in the upper part, we see that there are no results on years of schooling in Germany, as this variable is only available in the scientific use file. In Greece, for example, average literacy skills are 253 points. And the last table here gives the average over countries. And this is the second version of the command, including the over option, to get the results separately by gender. So we get the results for men where gender equals 1 and for women where gender equals 2. Next we have literacy skill dispersion. We use the summarize command to get percentiles, more precisely the 5th, the 25th, the 75th and the 95th percentiles. Again, as we are interested in literacy skills, we use the variable pvlit with the add character. With the by option, we calculate the results separately for all countries. But with the levels option, we only obtain the results for 2 countries, here Germany and Sweden. And as we do not only want the results for the full sample, but only for men between 16 and 34 years, we restrict our sample with the gender and age variables in the second version of the command. Here we have the results in the lower part for men between 16 and 34 years. We see that in the lower part the percentiles are lower in Germany compared to Sweden, but the upper percentiles are almost equal, and this indicates that skill dispersion is larger in Germany. The next example is on levels of numeracy skills. Before we can do anything about numeracy levels, we have to create a new categorical variable on levels. We do so with a loop to get 10 new variables on numeracy levels, each based on one of the 10 plausible values of numeracy skills. We simply call the variables num level 1 till 10. The categorization of the skill levels is based on the levels found in the OECD report. For numeracy levels, we can simply include num levels with the add character. The command frec calculates frequencies, and with the by option we calculate the results separately for all countries. We use an output file which we call Repest example 3a. And as we do not only want the results for the full sample, but only for employed individuals, we can also include the if option and restrict our sample with a variable cd05, which provides individual employment status. As we specified the output option, we don't see the results in the Stata output window. So we can go to our output folder. Here we have the 2 new datasets which we can open in Stata. For example, the results for all individuals. If we look at the data, we see that we have the share of respondents on each numeracy level and the respective standard errors for each country. For example, in Germany, there are 18% on the lowest numeracy level and 15% on the highest numeracy levels, which are levels 4 and 5 here. And from this dataset, we could also simply copy the results into Excel and create tables or graphs. Next, we come to numeracy skills and native language. This example is similar to the previous one. We use the frequencies command and also use the over option to get the levels of numeracy skills over native language. As we do not specify the by option here, we will get the results pooled for all countries in our dataset. But before we run the command, we have a look at the variable on native language. Apparently, some missing values are not declared as missings here, so we have to do this and we can run the example. The command to declare some values as missing values in Stata is mvdecode. And here we want the values 8 and 9 to be declared as missing values. For more information, you can have a look at the Stata help file of mvdecode. and here we go with our two groups. So then we run the command. We see that native speakers have higher skill levels than non-native speakers, which is not surprising as the skill assessment takes place in the language of the country of residence. Instead of frequencies of numeracy levels, we can also have a look at the average skills with the means command. We use the over option to get the results over the variable native language and also test for differences in skills between the two groups. Of course, this confirms our previous findings. Native speaking individuals have higher average skills than non-native speaking individuals, and the difference between the two groups are 33 points. The last example is on the correlation between all three skill domains. We include all three skill domains in the core command, and we calculate the results separately for all 5 countries again. Also, we calculate the average over countries. And here we go. Let's look at the results for the pooled sample. The highest correlation is between literacy and numeracy of 0.85, and numeracy and problem-solving skills have the lowest correlation of 0.73. Next, we have a look at the second form of the Repest command, which simply adds the prefix Stata. Remember, you have to add this prefix if you want to use E-class commands, which are typically regression commands. The first example is a linear regression on the question, how are age, gender, formal education and computer experience in the workplace related to problem-solving skills? And second, we use a logistic regression to check whether literacy skills and formal education determine participation in adult education for women between 35 and 54 years. Here we add the prefix Stata to the command, but apart from this, the syntax looks similar to before. We use the reg command as we want to perform a linear regression. Our dependent variable are problem-solving skills, so we include them directly after the reg command. Our independent variables are the categorical variable on age, gender, education in 6 categories, and a dummy on whether a computer is used at the workplace. With the by option, we calculate the results separately for all countries in our dataset. And we also want to see the number of observations and R² in our output window. In the second example, we want to perform a logistic regression, so we use the logistic command. The dependent variable is a binary indicator on whether a respondent participated in training, also called non-formal education. Our independent variables are education in 6 categories and literacy skills. As we use the levels option, we only get the results for certain countries in our dataset. And again, we want to see the number of observations and R² in our output window. And now let's go to Stata again. We use the reg command for the linear regression. Our dependent variable are problem-solving skills, and again we have to be careful to include the add character. Before we start with the regression, we also have a look at the variable on computer use in the workplace. So we recode this variable from 12 to 01 to ease the interpretation in the regression. Further independent variables are the categorical variable on age in 10-year bands, gender, and education in 6 categories. Again, with the by option, we calculate the results separately for all countries in our dataset, and we include number of observations and R². Let's look at the results for Greece. For example, individuals in the second age category, which are 26 till 35 years old, have on average 10 points lower problem-solving skills compared to our reference category, which are individuals between 16 and 25 years. Higher education goes together with higher skills. And individuals who use a computer at work have 13 points higher skills compared to individuals who do not use a computer at work. The second example is a logistic regression of training on education and skills. As we are performing logistic regression, we need to make sure that our dependent variable is a binary variable. So first, we simply tabulate the NFE12 variable. And this looks good. Depending on the data version you're using, there may be other labels here indicating certain types of missing values. In this case, you would need to recode the variable into a binary variable. Our independent variables are skills and education. And we only report the results for Germany and the United States. We have a look at the results for the United States, country 840. Note that the results reported here are the coefficients from a logistic regression, which means that you cannot interpret the size of the dependence between, for example, training and literacy skills. You can just see that education and skills are positively related to participation and training because the coefficients are positive. To obtain the odds ratios, which are easier to interpret for logistic regression, you can simply calculate the exponentiated coefficients. And this was the video on the Repest macro. Thank you for your attention.